Welcome back, guys and gals. We're still in functions. We've spent our last couple lessons looking at slope or rate of change, so how our situation with our linear functions changes. Today we're going to shift gears. We're going to look at something that we call a y-intercept. Right? If we were to graph a linear function, so let me just draw a nondescript x and y axis here. So here's our x-axis. Here's the y-axis. When we draw a linear function, all right, of course, it'll be a line, so let's draw one in. Maybe it looks something like that. All right. Our y-intercept, that word intercept, means to go across. So in this case, our y-intercept is wherever our line goes across the y-axis. So if I were to label that coordinate and give it its name, or location rather, maybe in this case it's at 0, I don't know, maybe it's 3 units up. All right. So notice it's at 0 for the x because from the origin I didn't go right and I didn't go left. I just went straight up, so 0. And then I went up maybe 1, 2, 3 units. I don't know. I'm guessing we don't have a grid line on. So all y-intercepts look pretty much the same. They're all going to start with a 0 because no matter if that line crossed up here or crossed down here, I'm not going to go left or right to name that location. So they're all going to start with a 0. The y coordinate, and whatever number it happens to be, is going to be where that line crosses the y-axis. So in this case, it's a 3 because it crossed up here at 3. Or maybe it crossed down here at -5, wherever it happens to be. Y-intercepts are important because that's where linear functions begin. All right, linear functions begin at y-intercepts. All right, and I'm going to abbreviate it with int for intercept, so I'm not having to write the whole word out. So here's what I mean by begin. Well, Mr. Moore, what are you talking about, beginnings? Let's take a look. We've got a graph here. What I've done is I've looked at the number of students, so that's on my x-axis, and I'm comparing that to the number of pencils, that's y. So remember, x is input or independent, and then y is output or dependent. And maybe I'm preparing for K-Prep at the end of the year. So I need to know how many students are in my room to know how many pencils I need to have prepared. I don't know, making something up. So for example, if I had 10 students in my room, then based on my graph, I go up here, so it meets right there, and I'll need 20 pencils. Or maybe if I have 18 students in the room, it looks like I'll need a little bit over 30 pencils in order to meet what I need. The question is, what happens at the beginning, right? Where does my information start at? Well, the information starts at what we call the y-intercept, right here. So in this particular case, my y-intercept is at the coordinate 0, 0. Notice right at the origin. So my x coordinate, in other words, number of students, is 0. And that means that my number of pencils, my y, is also 0. So that makes sense. If I have 0 students in the room, well, then of course I'll need 0 pencils. So this is our starting point for the situation, and it would go from there. If I had 2 students, well, then I would need so many. 4 students, I would need so many, and so on. But if I don't have anybody in the room, then I'll need no pencils. So that's what that particular coordinate means, that if we have 0 students, I need 0 pencils. All right, let's look at another one. In this case, I had a fish tank, all right, and what I did is I kept track of the number of minutes that elapsed. So 2 minutes later, 6 minutes later, 8 minutes, and so on. And over here, I was able to keep track on the side of the tank with the number of gallons that were left in the tank. All right, so imagine, if you will, I've got my great big fish tank here. That's not a bad drawing. And notice it's got all its water in there. And basically, I've got a tube in there that's just draining water out. Right? So if I look, for example, at the 12-minute mark, then it looks like I only had about 80 gallons left. If I was at, say, the 16-minute mark, it looks like I had only about 40 gallons of water left. But here's a question. Where did it begin? In other words, what did I start with? Well, if I backtrack my time all the way up to minute 0, Well, how many gallons does that relate to? So that's the y-intercept. Where does my line cross the y-axis? So in this case, it crosses at 200. So my coordinate there would be 0, comma, 200. And the meaning of that point is that at 0 minutes, or in other words, before I started draining the tank, there were 200 gallons in the tank. So again, our y-intercept doesn't tell us really about the change of the situation. Notice in this case, the change is that I'm losing water, whereas up here, the more students I have, the more pencils I need. The y-intercept gives me some idea of what the situation started at. So in this case, at 0 minutes, I still had 200 gallons of water. But as soon as I started draining the water out, notice that rate starts to decrease. But we're not focusing on rates today. We're focusing on where did we start. All right, let's look at another one. In this situation, we're looking at the number of hours somebody worked and the amount of money that they've earned. All right, so for example, at 5 hours in of wherever they've worked, looks like they're at $25. Or if I were to guesstimate, say at about 7 and change, 7 hours, 7.5 hours, somewhere in there, it looks like they've made close to $35. All right, but again, where did they start? So before they started working, how much money did they have? That's the y-intercept. So if I go down here, my y-intercept is right there. It's at the coordinate. Remember, all y-intercepts start at 0, comma, some number. And in this case, the number it happens to be at is 5. So I could read that and understand this number, 0, comma, 5, is that at 0 hours, so in other words, before this person started working, they already had $5. Maybe they had $5 in their wallet or $5 in their savings account or wherever. So I could say, before work began, the individual had $5. Cool. So the starting point, the beginning, where did this situation begin? And a lot of times with graphs, it's just as simple as looking at the graph, seeing the point, and understanding what it means. So if your x and y-axis are labeled, well, then we can figure it out pretty quickly. Remember, x goes first and y goes second. So at 0 minutes, we had 200 gallons in the tank. Or at 0 students, I need 0 pencils. Or at 0 hours work, the person already had $5. So we need to understand what it means. There is a situation, though, and let's draw a line here to kind of separate it. There are situations, though, like this one, where I've got a graph, I can see what's going on, but I can't tell where my line would cross the y-axis. So notice, this is the number of weeks that a particular business has been open. So notice we've got 10 weeks, 20 weeks, 30 weeks, 40 weeks, and just a little bit past 50 weeks would be 1 year, about 52 weeks in your typical year. And so on. So we've got almost 2 years worth of data here of space. And notice it says dollars earned. All right, so maybe this is dollars earned in terms of profit, dollars brought into the cash register, who knows? But notice I don't see where this line crosses the y-axis. If I wanted to see that point, what I would need to do, and I'll grab a pencil here to draw it kind of lightly, I would have to extend my y-axis down. Let's grab a red pencil here. And we would have to extend the graph over to see where that would cross. And the problem is I have no way of accurately drawing this to make it work out. So in situations like this where I don't have a nice, neat point that I can say, oh, look, there it is, we're going to have to do a little work. All right, so let me show you how to do it. First step. Okay, make sure you write this down. First step, pick 2 points. And what I mean by that is pick points that are nice and easy to read. For example, this point right here is very easy to read. It's at 60 weeks worked, and it looks like $20,000 earned. So let's write that down. So this first point is at 60 weeks and $20,000 All right, cool. So that was an easy point to pick. Let's find another one. For example, I don't want to pick, say, this point here. All right, that's going to be kind of tough to read. I'm not sure how many weeks that is. I'm not sure how many dollars that is. So I'm going to stay away from that. That's not going to end well for me. Let's find an easy point. This point right here looks really simple. It's at 40 weeks. Let's write that down. So at 40 weeks, and it looks like money earned is at a 0. That seems kind of odd for a business, but we'll write it down. Now, pick 2 points, done. All right, second step. Now, I know I told you today we're focused on Y-intercepts, but that's not 100% true. To do this, we are going to need to find the slope. All right, well, we found slope. We've done this a number of times, so let's do that. So remember, our slope formula, I'll write it over here, is m equals y2 subtract y1 over x2 subtract x1. Okay, so I'm going to make this one here coordinate 1, and we'll make this one here coordinate 2. Again, it doesn't matter which one, just so long as you label it. So here we go. I'm going to take 20,000, because that's y2. So 20,000, I'm trying to write this small to get it to fit. Subtract our y1. Well, that's easy. That's just a 0. And then for our x's, so we've got 60. Subtract, what is that, 40. All right, let's see what we get. And I'll write it over here into the graph. It'll be okay. So 20 subtract 0, that's 20,000 over, let's see, 60 subtract 40, well, that's 20. And notice, I can simplify that. 20,000 divided by 20 is just, looks like it's just 1,000. All right, because 2 goes into itself once, we can cross out an extra 0, so 1,000. So it looks like our slope is $1,000 for every week. Cool, so we're going to need our slope. Excellent. Step 3. Now, we've talked about slope-intercept form. All right, we talked about this a little while ago, where our format for all of our equations is y equals mx plus b. Remember, m is the slope, x is the independent, y is the dependent. All right, so what I'm going to do is I'm going to take my x, y, and m and fill in what I know. For example, I know a y coordinate right here is a 0. I know that its x coordinate is a 40. Okay. M, remember m we said was just our way of talking about slope. Well, we just found the slope. The slope is 1,000. So I'm going to write that in. 1,000. So we've got 40 multiplied by 1,000. We got our 0 plus b. Here's the deal. The b in our equation represents the y-intercept, right? In this case, where our line is going to cross. If we solve this equation, we'll know where our line is going to cross. Let's do that. So 0 hasn't changed. 1,000 times 40 is 40,000 plus b. All right. Well, I need to subtract 40,000 on both sides to get that b by itself. So let's do that. 0 subtract 40,000 is a negative 40,000 equals b. Awesome. So there's our y-intercept. But remember, all y-intercepts look like this. 0, comma, a number. So let's write it that way. So the 0, remember, that's always going to stay true. So 0, comma, and then our number. In this case, our number is negative 40,000. Excellent. So this coordinate way down here is 0, comma, negative 40,000. All right, but what does that mean? Well, that means at week 0, so when the company started or when the store opened, whatever this is, small business, they were already $40,000 not earned, right? Because this is negative, 40,000 in debt. And that's typically how businesses start, folks. You got to buy equipment, you got to hire people, so you're going to be in the hole. So we could say at the start, oops, forgot my T, at the start of the company, we'll say, they owed $40,000. And that's what that point would represent, that before business started, they were already $40,000 in debt. And then notice each week they were able to add on $1,000 a week to gradually pay off that debt. And then right here at week 40 is where they start seeing profit. Looks like $1,000 each week. So it almost took them a whole year before they saw profits. And that happens a lot of times, folks. If you want to start your own business, that's sort of the truth of the matter. All right. So if we're finding y-intercepts using a graph, that's how we do it. We either look for that spot and just pick it out, or if we don't see it, then these are the steps we work through. Pick 2 points, find the slope, then we'll use our slope-intercept form. Slope is here, intercept is there. Plug in an x and a y, plug in your slope, and then just solve for b. And that number is your intercept. All right, cool. Well, let's flip the page over. Let's look at how do we find y-intercepts in a table. And it's basically the same as a graph. All right, take a look. Here's what I mean by that. Remember, all y-intercepts, all starting points look like this. 0, comma, a number. So if you can find that, well, then you found your y-intercept. Now notice for these first couple of tables, we don't have any context. There's no story. So we'll just record them as they are. Well, notice in this first graph here, x is 0. Cool, that's what we're looking for. And then here's that other number. So in this case, my y-intercept is right there. So the y-intercept for this first table is just 0, comma, 0. Excellent. All right, well, that was easy. All right, let's try this one. Again, we're looking for where x is 0. There it is. And then we're looking for the number that goes with it. Awesome. Well, in this case, 0, comma, -1. So 0, comma, -1. So there's our y-intercept. That's where we start. Looks good. All right, well, let's look at this one. Uh-oh. Notice in this case, I don't have a 0. I've got 6s and 10s and 12s, but no 0. So I'm going to do the same steps that I did here with my table. So let's go through it. Now I'm going to use a pencil just in case I make a mistake. We can erase it. So first step is I need to pick 2 points. All right. Well, I don't want to use any of these because those decimals are terrible. So I'm going to pick this coordinate and this coordinate. Remember, you can pick any 2 that you want. It doesn't matter. And I'll let this be 0.1 and I'll let this be 0.2. So now that we've picked our points, let's say pick 2 points. Cool, we did that. Second step, we need to find the slope. Okay, we can do that. So we'll take 46 and subtract 44. So remember, y2 minus y1. Now I need the x's. So 12 subtract 6. All right, let's see what we get. Well, 46 subtract 44 is 2. 12 subtract 6 is 6. 2 over 6 we can simplify, right? We can divide both those numbers by 2. So our final slope is 1/3. All right, 2 divided by 2 is 1. 6 divided by 2 is 3. So cool, there's my slope. Third and final step, we're almost there. We're going to use y equals mx plus b. That's our standard slope-intercept form, right? Not standard form, but slope-intercept form. And we're going to plug in what we know. And for my x and my y, I'm going to pick these numbers just because they're small, for no other reason than that. Again, I don't want to pick a number like this. I don't want to have to deal with all those decimals. Terrible. So the y is 44. So I'm going to take y out and put 44 in its place. My slope is 1/3. So let's write that in, 1/3. My x, so we're going to multiply it by x. X in this case is 6. And then we're going to add b. Looks good. So let's solve it. 1/3 of 6 is 2. So let's write that down. So 44 equals 2 plus b. All right, this is a one-step equation now. We can solve that. We'll subtract 2 on both sides. So subtract 2 here, subtract 2 there. We'll get 42 equals b. Awesome. So that's my intercept. So to write that in, I would write it as 0, comma, 42. And there it is. So this particular table would start at 0, 42. Cool. All right, well, let's talk about some with context. Notice instead of x's and y's, we know what there are. So in this case, time on the road is our x, our independent. Our distance traveled would be y. And remember, all of our y-intercepts look like this. They all start with 0, comma, a number. Well, notice here's our 0, cool, and it's at 210. So if I were to write that as a y-intercept, I could write it as 0, comma, 210. And if I wanted to talk about its meaning, well, it looks like we haven't spent any time on the road yet, and we're already 210 miles in. So maybe we're driving for 2 days, right? We've already traveled one day, and maybe this is the start of the second. So we haven't gone anywhere yet, but we've already been, at least in terms of time, but we've already traveled 210 miles. Maybe we traveled that the day before. All right, so that's how we could explain what that means. All right, let's look at another one. Notice in this case, we don't have a 0. Crud. In this case, the number of days rented and the cost of, maybe we're renting a car. All right, so we need to go backwards in time to day 0. Day 0 in this case would be, what would the car cost me before I've been anywhere? All right, and if you've ever rented things, sometimes they have a fee that you pay up front. So what we're looking for in this case is, what is that fee? All right, that initial fee. All right, and again, a lot of times in rental situations, if you want to rent something, they're going to charge you maybe per day or per hour, but they're also going to charge you a little something up front. So that's what we're going to figure out. Well, I notice in this case that we've got some decimals, and I want to try to steer clear of those as best I can. They're going to make the math more complicated than it needs to be. So I'm going to pick whole number answers. So in this case, 6 days for $270. That looks good. And then this one down here, again, nice whole number. 12 days for $405. I don't know what they're renting, but heck, it might be cheaper just to buy it. I don't know. So here we go. First step, we've already picked our 2 points. Remember, step 1, pick 2 points. Cool. We did that. Step 2, and I'm going to do it down here because I'm running out of space. Step 2, we'll do down here. We need to find our slope. All right. And again, just to show you that it doesn't matter, I'll just do it this way. We'll say this is coordinate 1, coordinate 2. I don't want to end up with some nasty numbers here. So we'll do it that way. But again, you could reverse it. You could make this point 2 and this point 1. It's your call. So y2, right here, remember, x's tend to go first with y's tending to go second. So we need $405. Subtract 270. All right, and we'll do that math here in just a second. The next thing we need is our x's. So in this case, 12 goes first. Notice the 405 and the 12 match up, so 12 needs to go first. Remember, that's x2. And 12 subtract, 6? There we go. All right, so let's do that real quick. So we're going to take 504, we're going to subtract the 270. That gives us a cost differential of $135, just to keep that in mind. And then 6 from 12 is, of course, 6. So it's going to cost me $135 every 6 days. Now, I don't know about you, but that really doesn't speak to me. That really doesn't say a whole lot. So I'm going to go ahead and divide that out. And that's going to get me a dollar amount of $22.50 for every 1 day. So it looks like whatever we're renting here, maybe it's a car or a leaf blower or who knows, $22.50 every day looks good. So step 3. Step 3. We're going to use y equals mx plus b. That's sort of our standard format for a linear situation. And we're going to plug in what we know. In this case, I'm going to go ahead and use that first point again, just because the x's and y's are small. No other reason than that. So the y is here, 270. The m we just found is $22.50, and we're going to multiply that by x, in this case 6, plus b. Remember, we said in this case we're going to have some sort of initial fee, some dollar amount that they're going to make us pay up front before we ever catch a glimpse at that rental car, that leaf blower, whatever it is we're renting. All right, so we need to take $22.50 and multiply that by the 6 days. So that, well, we kind of did that already, didn't we? So 270 equals 135 plus b. We need to subtract. Remember, we're trying to get b by itself. So I'm going to take that 270 and subtract the 135. And what do you know? That's 135. So our ordered pair, if we want to write it that way, in this particular case, would be 0, comma, 135. So that's the y-intercept. And if we were to write it out for what it means in this situation, we would say that the initial fee is $135. All right, there it is. There it is. So let's keep going. We got one more. Again, no 0. And notice we've got decimals, so we want to be selective here, but we want to figure out what will it mean? What will that 0 point be worth? So again, let's review the steps. First step is pick 2 points. So I'm going to pick whole numbers. I'm going to pick this coordinate here. And, oh, we got another one. This coordinate here. Cool. Step 1's done. Step 2, we need to find our slope. So let's do that. So coordinate 1, coordinate 2, here we go. So 34, subtract 37, because remember, y2 minus y1. Now we need to do the x's. In this case, our number of students is going to determine how many pizzas are remaining. So maybe it's a basketball game or something. However many students show up to the game is how many pizzas we'll end up with. All right. Let's see. Number of students for 2 is 24. And for 1 is 12. All right, so let's subtract. It looks like 34 subtract 37 is a -3. Make sure you put that negative on there. And then 12 from 24 is 12. So that means 3 pizzas. So in other words, we're going to lose 3 pizzas for every 12 students. Remember, dependent over independent. I don't know about you, that seems kind of weird. So I'm going to simplify that fraction. So -1, so we're going to lose 1 pizza for every, let's see, if we divide that out, we would have 4 students. Cool. So 1 pizza for every 4 students. Another way to say it is that every student would eat a quarter of a pizza. All right, cool, easy enough. Now that we've got that, our third and final step, y equals mx plus b. That's our format. And we're just going to take 2 of these points and plug them in. I'm going to use the first one. Again, the numbers are small. So our y is 37. Our slope is -1/4. So let's write that down, -1/4. Multiplied by x. So in this case, for 37, its x, its input is 12. Plus b. Here we go. 37 stays. -1/4 of 12 is -3. Again, I could take -1/4 and multiply it by 12. So we get -3 plus b. Remember, we want to get b by itself, so I'm going to add 3 to both sides. Since this is a -3, we're going to add it. So add 3 here, add 3 here. Looking good. 37 add 3 is 40. Cool. So our initial value is 40. So if we wrote that as an ordered pair, we would write it as 0, comma, 40. Another way of saying it is that if 0 students show up, there will be 40 pizzas. And maybe this was, like I said, a basketball game, and this is for the snack bar or something. Maybe they ordered 40 pizzas, and they know that 1 pizza is going to be lost for every 4 students that show up. All right, so this is what we're focusing on today. We're not focusing so much on our rates as we are what we're going to call a y-intercept. Where does our line cross the y-axis? And if we can see that either on the graph or on the table very easily, well then cool, all the easier. If we can't, so in situations like this where we didn't see that y-intercept very readily, or in cases like this where we don't see the y-intercept as readily, we'll need to follow these steps to figure it out. Again, make certain that you bring your notes with you to class. We'll talk about it and answer any questions that you might have and get started on our work. All right, have a good day, folks.